Okay. Don't. Okay, buddies here. Right. So like other RISC or reduced instruction set computer, MIPS are load store architectures. In MIPS, all operations perform only on operands in registers. Okay, however, this would lead to insufficient storage since we can only use 31 variables in the program. Sometimes we need arrays of values or need a place to store a value when you run out of the 31 available general purpose registers and need to use a single register for more than one variable. So it is very important to learn how access the computer's main memory. So as I have mentioned before, our coding use a lot of data. Use a lot of data whereby you load your coding, from your hard disk to your RAM, right? To your RAM. So it's like inside a block. Okay, they are inside a block. And then this block, will be this block will be separate. Will be divided into a smaller block so that it can be loaded into a cache. So your cache contain instruction and also data. It will contain instruction and also data. So do remember when you try to write a CPP file, your C++ program, it will contain variables. The variables that you have initialized or constant, right? And then maybe arrays, maybe arrays and everything else. So all this is a data, that you want to operate later on. So they will load it into the data. So how do we want to access these variables or maybe a constants or maybe arrays? By using the load and store architectures. So the reason is that MIPS only have 31 registers that you can use at one time. At one time. So let's say you have a lot of operations that needs more than 31 registers. So what you can do is that once a certain variables or certain operation has been completed, and then you want to store it back into the cache. So this is the CPU. So once you have execute the operation, then you will store it back on the cache. So that the data maintain its consistency. They would maintain the consistency, so the value would not be error. There's no error in the data. So that's why you use the memory. You still need to use the memory. So everything, instruction, data are all in address. Must be addressed, and then they are stored inside the memory. So when I say memory here, it's main memory. Now to transfer a word of data, we need to specify two things. One is that you need a register. That one is to registers. I said registers is because of one register is to use as the base register. Another register is to use for holding the data for you to process it. And then you need also a memory address. Specify the address by supplying a pointer to a memory address. The memory can be visualized as a single dimensional array. I'm not sure if you have learned so far about array, but I'll just tell you in like a simplest form. Array, for a single dimensional array means that you only have one column and many rows. One column, many rows. That's what we call a single or one dimensional array. One dimensional array. So in this case, I can create marks for student. For marks for student. For example, your marks for midterm exam. Example, marks for midterm exam is 30, 40, 50, 10, like that. And then how do I address this number? Using an index. Using an index. Okay, so start with 0, 1, 2, 3, like that. Okay, but in actual reality of the memory itself, okay, hold on let me mute my phone. Min, hold on. Siapalah kacau saya ni? Nak kena ni. Okay, done. Now I'm done. Now, so in actual reality, this is inside your coding, right? Inside your CPP file, you refer the value using index. Okay, you refer the value using index. So you always start at 0, 1, 2, 3. Okay, but in actual reality, inside the assembly programs, okay, these index are referring to the address. Everything is addressable. So, macam mana saya nak select benda ni? The resize kan? No, not resize. I want to select. I want to close out this part. I want to remove this part. Okay, now I can draw. So in actual, okay, in assembly, okay, those index, where's my pen, can be referred as address. So let's say the actual in QtSpim, they always start at 1001, 0001, and then the next one is 1001, 0004, then 1001, 0008, and then 1001, 000C. Okay, so in this case, as you can see, each of these data is treated as 32-bit binary data. Okay, the size of each data is stored in a 32-bit binary data. So, 32 bits is equal to 4 bytes. So, for the programs to access each of these index, they must add 4 bytes, 4 bytes, 4 bytes. So, that's why you can see the address here, okay, increment plus 4. Okay, plus 4 means 4 bytes. So that's why 1001, 000, and then 1001, 0004. Okay, because they increment plus 4. And then also this one, 4 plus 4 is 8. 8 plus 4 is C. So in this case, this is hexadecimal address. Okay, they shorten it to become a hexadecimal address. Okay, so this is the reality inside your memory. Okay, but in your program, we refer it as index. We start at 0, 1, 2, 3. We don't look at the exact value of the address itself. It's because of CPP is close to the user, whereas your assembly program is close to the machine. So we need to think like a machine when you write into the coding of your assembly program. But so that's, you need to know the nature of the memory itself. The nature of the memory. So that's why we need the memory address. Okay. So in MIPS, data transfer takes place from the memory to the register by using the command load word, load half, and load byte. Whereas for the data move from register to memory. Okay, so from register to memory means that we want to store data from register to the memory. Then we can use the command SW or store word. SH is store half word. And then store byte means store 1 byte of data. Okay, so there's a meaning there for each of this command. You can look at the MIPS screen sheet. And then look at the store. Okay, we have a store byte. Okay, store byte means that you store only 1 byte of data. So they would look into the size from bit 0 until bit 7. So bit 0 until bit 7, then you will get 8 bits of data that you need to store into the memory. Like that. Okay, so there's a difference there. One is a store byte, one is the store half word. Half word means 16 bit, and then store word means 32 bits. Okay, so the only instruction that access the memory are load and store. Regardless if it's a load word or load half or load byte. So any instruction that comes with load and store, so means that they access the memory. They will access the memory. So MIPS does this by using a pointer to location in memory where data is stored. Okay, you need to point somewhere. You need to point where is the data. So the starting of the data start at index 0. So then you must have a pointer to the index 0. Okay, must have a pointer to the first index of your memory. So usually we use address. We will use address that contain the pointer. Okay, so even if you learn in C++, if it says a C pointer, and then they will ask you what are the content inside the pointer, basically it is an address. Basically it is an address. But it looks weird. Very, very weird because the address is in hexadecimal. Okay, it's in hexadecimal because of the size of your memory is so big. Okay, so you will get a different type of memory address. But in this case, it will not be like in your QtSpim. QtSpim is only a small size of RAM. So don't compare the memory address in your assembly and memory address inside your CPP file. Don't use that. So but just know pointer means address. Okay, pointer contain address. Okay, so the value of an address tells us where our values are in bytes. Okay, so alamak, not 8-bit increments, but actually it is in 32-bit increment. Salah lagi. My mistake. My mistake. Sekejap Let me color it. Okay, let me shade it so that I would remember to do that part. So the value of an address tells where our value are in bytes. Okay, in bytes means that it must be increment in 4 bytes, 4 bytes. As you can see here, this one, right? 048C. So there is an increment of 4 bytes, 4 bytes, 4 bytes of the address. So to, let's say, start with the data transfer, load. Okay, so we want to load data from memory to register, then we use the command load, right? So to specify a memory address to copy from, we need to specify two things. One is the register that containing pointer to a memory, and then another one is the numerical offset, which is in byte. I usually use a byte because of that. The QtSpim doesn't know how to access it in half byte or whatever it is. It's always, the numerical offset is always in bytes. Okay, 4 bytes, 4 bytes, 4 bytes. Okay, so it is in, we say that in the number of multiplication 4. Okay, so you need to see, you need to count it. So the effective memory address is the sum of this offset plus pointer. Okay, for example, if the coding, okay, this is half of the coding, So if the coding write offset it and then with the bracket of T0, so whereby T0 contain 1000000. This is only an example, The actual one will be different, lah. Okay, so they only give you just a sample of question, just a sample of address. So 10000000. So this is the pointer. Okay, contain the base register, contain the base address for pointer T0. So this command would specify the memory address pointed to by the value in T0 and then plus with 8 bytes. So the effective address would become 10000 plus 8. You would get the target. Okay, the target address is 10000008. Betul ke ni? Sekejap. Yes, correct. This one is 8 byte. Sorry. This is 8 digit. So now we can get the effective address. Okay, now let's say we want to load from this address. You want to load from the address. So how do we write it? So we use the command load word. Okay, where 32 bits or one word are loaded at a time. So when we load when we use the command load word, so data will be in 32 bits. Okay, the data will be in 32 bits. Okay, now load word is an I format. So we have 4 field op, base or RS, and then RT and offset. Okay, so for example, sorry, hold on. Alright. We have load word T1 and then 4 T2. Okay. Now, look at the right side first. Look at the right side. We have an offset. So, offset here is your immediate. And then T2 within the bracket is your pointer or base register. Okay, write it as base register. You must write it in as a base register. So here it says that this instruction will take the pointer in T2 and then add 4 byte as the offset and then load the value from the memory pointed to by this calculated sum. When they add T2 content inside T2 and 4, you will get the targeted address. And then the targeted address, okay, will be looked into the memory and then they will load the value from that target address into T1. T1 here is your target register. Target register or your destination register. So LW is your OP, T1 is your RT, T2 is your source. Okay, because it contains address that you need to look into. Okay, so T2 is your base. Okay, so anything that is within the bracket will become your RS. Okay, so RS or base here. Let me write RS there. Macam tu okay, now. And then, where do we want to load the data? The thing that we calculate, 4 plus 4 here will become your offset, right? So 4 here is in decimal because it doesn't have 0x in front of it. 0x. So if it's a 0x, dah manalah perginya saya punya ni. Ni kan. Okay, if it has a 0x, then it would become hexadecimal. But at the moment, this is not hexadecimal. This is a decimal. Okay, so 4 will be put into immediate section and then T2 will become the base. Okay, so this is the encoding of the machine instruction. Okay, now when we decode it, okay, so what happened is that ALU, okay, the processor will load the content inside T2. T2 contain 10010000. So where does 100100 does come from? From the memory here. Okay, the memory here start at 10010000. So I'm following the QtSpim value, right? So it the address start from here. Okay, then it was loaded into T2 to become a base register. Then the content or the pointer address is loaded into the ALU and then added with the offset which is 00000 and then 100, which means 4, right? So 4. So add 4 with the 1001, 0000, then you will get the effective address 1001, 0004. Okay, so once you have received the effective address, okay, then they will look into the memory. They will look into the memory where is the address of 1001, 0004. Okay, and then they look into the content of that address and then take out the data and then pass it back to the register file. So this is the inside the register file. So where do they want to load into? So it says here load word into T1. Then 10000 D8 will be loaded into T1. Now the T1 will have this value. So this is what it means load word. Okay? Next. Now, beside load word, we also have apa? Next, load byte. Okay, load byte also can be written in the coding. Okay, if you just want to have only load byte, sebab tak ada dia at the moment they only have load byte unsigned, but actually we also have load byte. Okay, so load byte is 20 hex actually in this case. Write an instruction that loads the byte and address. So how many is byte? How many is a byte? So if I say load byte, okay, but the address or the value here is basically like A, B, C, D, E, F, 10. So which value should be taken out? Okay, should be load into the register. Okay, for example, I will write T1 and then offset anything lah, offset 4 and then T0, for example. This is an example. So when they load the, when they calculate the effective address, it will point to this value. Okay, it will point to this value. So when they take out, okay, they see, okay, this is the value A, B, C, D, E, F, 10. But they only ask to load 1 byte. Load byte means only load 1 byte. So what they would load is that A, B, C, D, E, F, 10. What you have is 8 digit of hexadecimal, right? So each one hex contain 4 bits, 4 bits, 4 bits, right? So you only need 1 byte. So how many 1 byte? Means that 4 bits plus 4 bits. Then you will get 1 byte. So only these 2 digits would be loaded to the T1 like that. Okay. So for example, if you want to write an instruction that load the byte address at 10010040 into register T0. Assume T1 contain the memory address, the starting address 1001 00000. If the content of address 0x10010040 is ABCDEF10. So what is the final data contained in destination register? Okay, so based on this command, okay, it has load byte, means that they only want to take 1 byte only. Okay, from the target address. The target address comes from the base register T1, which is start at 10010000, and then plus with the offset, okay, plus with the offset from, how do we get the offset? Okay, we have the target address here, 10010040, right? So the offset is target address subtract with your starting address. Okay, target address subtract with your starting address. So your offset is target address minus your starting address. Then you will get your offset. So in this case, 100100, tadi berapa tadi? 40 subtract with 1001 0000. So what would you get is 0000040. Okay, so then you would need to write on your coding. Okay, load byte, and then load the byte into T0, your destination, and then your base register is in T1. Your offset is here. You can see that it is 40, right? So you need to write 0x40 like that. Okay, like that. So the final content of T0, for example, if the content is ABCDEF10, so they only need 2 digits of hexadecimal, then the final content is 0000010. Okay, no, it should be 0x. Macam tu. It should be in 0x. Sorry, like this. Okay, please correct that notes. Alright, so the opcode for load byte is 20, 20 hex. And then T0 is the destination, and then T1 is your base. Okay, so your base register, so 1001, and then 0x40 is your offset. Okay, is your offset. And also, there's a mistake that part in the previous notes. Okay, the one that you have downloaded so far. Okay, so please correct that part. The value should be like this. So when I separate it, so it should look like 4, and then there's a 0 there. So then you will get the correct offset for your coding. Okay, so that's it for that encode. Now, T1 contain 1001, 0000, and then with the offset of 40, 0x40, when we add, we will get the effective address 10010040, right? Okay, and then when they want to load, they only need to look at the coding, the command, the opcode is load byte. So when they see load byte only, so they only take out the byte, 1 byte of the lower part. 1 byte of the lower part of the data, and then they will load it into T0 there. Okay, so this is in hexadecimal. Everything is in hexadecimal in this case. Okay, now next example is that, okay, so this is like a trace table. This is like a trace table. Register before the execution of the command, and then register after the command, and then what happened inside the memory data. So look at the registers T0 and T1 and the memory specification here. We start, we have 10010000 here until 10010014. So write an instruction that puts the value 0x000004 into register T1. Okay, so where is 00004 here? It's there on the address 10010010. Okay, so what would be our offset? So you remember when I said target address minus starting address, right? So target address here is 10010010. So 10010010 minus 10010000, then you will get 00000010. So your offset would be 0x10. Okay. Then you have the T0 as your base register. Okay, the content here is shows that T0 become the base register. So put a bracket on the base register and then put T0, and then the offset is from the calculation that we have made. You will put the hexadecimal 10. Sorry, not 10, 10. Okay. And then where do we want to load? We would load it into T1. Write an instruction that puts the value of 0x0004 into register T1. Okay. So in this case, when we load, okay, 4 into T1, So the previous value would be override. Okay, it would be replaced. So that's why the content of the register after this command load word would change, especially T1. But what about T0? T0 doesn't change. Okay, the only effect, the register that affected is only T1. Okay, next is the store word. If we want to transfer from register to memory. For example, after you have do the operation, for example, add two numbers and then please store it inside the memory. Just like that. So add two numbers and then store it back into the memory. So when you do the operation, first you do the operation add, and then the result, you want to save it inside the memory. So what do you need? Is the same thing as the load word. You need a register containing pointer to a memory and then the offset in byte. Store word, we would use a store word where 32 bits or one word are copied from register to memory. So the value of destination register remains unchanged. Okay, so in this case, RT doesn't change. The only thing that change is the data or the memory data. Okay, so identical to load instruction, store instruction use the same I format. So on the example, consider the following instruction: store word T1 for T2. Okay, so previously we mana yang tadi? Mana T2 tadi? T2. This one. Okay, previously we load the data in memory. Okay, using the offset 4. And then load it back into T1, right? So T2 become the base register. Okay, now we want to save it back on the same memory. Let's say they want to save it back on the same memory. So I use store word T1 for T2. So what happened is that this instruction will take a pointer in T2. Okay, so T2 contain 10010000. Here's the starting address, right? And then add 4 bytes as the offset here. So when they calculate 4 plus 10010000, you will get the effective address 1001,004. Okay, so now you have the target address. Then what do you need to do? You want to save the content inside, the value inside T1. Okay, so the value inside T1 contain 1000D8. They would load back, they would store back into the memory that is assigned. Okay, that is calculated, which is the effective address here. So then they would replace the previous value with the new one. With this new one, 1000D8. Okay. Now, let's say we have a different style. Okay, different style of offset. So look at the register T0, T1 and memory specification here. We have T0 with the base address 10010014, and then T1 contains 0xFFFFFFF. Okay, so if you look at the content of the base address here, okay, so basically your starting address start at the top one, 10010014 here, okay. And then to access the other elements, okay, then you need to decrease the 4 byte. So decrease 4 byte, you will get 10. Decrease again, you will get 0C, and then decrease 4 byte again, you will get 08. Decrease, okay, subtract 4, you will get 04. And then subtract 4 again, you will get 00. Okay, so this is another style they use a negative one. So the first instruction of the answer, okay, sorry, read back the question. Write the instruction that puts the word FFFFF, okay, this one, on the content of T1 here, into memory location 1001,000C. Okay, the starting address is at 100100014. And then you want to put it inside 1001000C. So what is the final data contained in the memory location? Okay, so the instruction is you can have two style. One is that you represent using hexadecimal. The other style is using a decimal. So how do we want to calculate that? Okay, how do you want to calculate that? So now, dah pergi mana my brushes ni? Okay, now you have the target address is 1001000C, and then your starting address is 100100014. Okay, so your offset is by subtracting this number, target address with the starting address, then you will get the answer, right? But at the moment, when you look at the value, you will know the target address is small, okay, smaller than the starting address. So what you will do is that you just subtract it as in the normal way. So in this case, 1, 4 minus C is that 1 becomes 16. 16 plus 4 is 20, right? So 20 minus 12. So you will get 8. Okay, so in this case, you will put a negative there. So in hexadecimal, it will become F, 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 like that. Okay, so since the offset can only contain 16 bits, so you only need to take 4 digits of hexadecimal from the calculation to be the offset for this instruction. Okay, or if you don't want, if you are not sure of the answer for the hexadecimal, then you can just put a negative 8, because you know here the position start at 1, 4, right? So minus 4 become 1, 0, minus 4 become C, like that. So then you should know how many cell that they need to jump. One time, okay, and then second time, so means that 2 times that you need to jump. So 2 times 4 byte means 8. So put a minus because the value must decrease, then you will get your offset. So negative 8 with your offset. And then your store word, your target address, your target register is in T1. So store word T1, comma, negative 8, and then with the base address, base pointer T0. Okay, so your final content of the memory location of 1001000C, once you have store word, 3 would be replaced with F, 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 F. That's it, like that. Okay. Now, how do we want to start with your load word? If you start with your load word, it would expect, the coding will expect an address. So before we want to write your coding of your load word, you must prepare your base register. How do you want to prepare your base register here? It must contain address. So how do you want to do that? Okay, first is that make a reference to a memory by using a 32-bit register and an offset. So how does the base address get into the base register? So how do we want to load address, a memory address, into S0 or maybe T0? So to load, okay, we cannot use the load word or store word. Okay, cannot use that because if you look at the format, load word and store word use I format. And then when you look at the constant here, the immediate can only contain 16-bit only. Okay, they only can contain 16-bit. So let's say if you want to use a load word or any immediate constant, then they cannot load it. Okay, so immediate implies the constant is part of the instruction. So we use load upper immediate. Okay, so why are we not going to use the or immediate? It's because of, let's say if I use or immediate. Okay, or immediate register as 0, comma, register 0, and then you want to write, okay, you want to load, sorry. Start with, okay, where do we want to start our memory address? Where do we want to start our memory address? It start from here. 10010000. Okay. So, but basically when you start your coding, it always start at 10000. But due to the coding, they cannot, the Qt Spring cannot start with 10000 here, but instead of, it can be start from 10001. Okay. So, how do we want to load address of 1001? Okay, 0000. So you want to load this into the register of a base address. So for example, we want to load into register S0 as your base register. So let's say if you want to load or initialize, you can use or immediate and then register S0 and then register 0. Okay, so and then you can use a 16-bit. Okay, 16-bit of hexadecimal. So 0x1001. What would happen is that the content of S0 here, okay, if you use or immediate, okay, the content would become 1001 and then 0000, like that. Okay, so if you are using or immediate, the immediate here is referring to the lower part of the 16-bit. Okay, not the upper part of the 16-bit. Okay, do you get what I mean? So now, if we are not, if we cannot use the or immediate, then to load, okay, so to load the upper 16-bit here, to load the upper 16-bit, then you need to use another instruction, which we call load upper immediate. This one, LUI, load upper immediate. So it will copy 16-bit of the upper 2 byte. Okay, upper 2 bytes of the designated register. So in this case, 1 byte plus 1 byte, then you will get upper 16-bit can be loaded into the upper half of the registers. Now, how do you want to do that? Okay, we can refer on the example 9.6 here. Okay, by referring to the memory content above, write a code snippet to load the word 0040010 into T0. So T0. So in this case, they want to load the memory, the content data inside the memory at address 0040010, right? So the starting address start at 0040000. This is an example. Just treat it as example. So the memory address start at here 0040000. Now, how do we want to point this starting address into a register? So here you are expected to load this address into T1. So what are the command that we need to write? So first is that you use load upper immediate and then T10 0x0004. So what happened is that, when you write load upper immediate and then T4 with 0x0004, okay, so the inside of the T4 would become 0004 and then the lower 16-bit would become 0000. Okay, now is this the same as the starting address here? Yes. Okay, as you can see, the content inside the T4 now is pointing to the memory address, the starting of the memory address. Okay, and then once we have T1, oh, actually this is T1 My mistake. This is T1. Okay, so this is T1. Now, T1 contain the memory address, the starting memory address. Now, we can load. Okay, load memory at 0040010 into T0. So, we can use the load word. Now, we can use the load word because T1 contain the base address, the starting address, 0040000. So, T1 contain the starting address, and then what is the offset? Offset is the target address, which is 40010 minus or subtract with 40000, then you will get 0x10. So this is the value, okay, in hexadecimal. And then once you have the target address, then you can load it into T0. So this is the usage of load upper immediate. Okay, so now if you are required to load example this one, write the instruction so that register T1 would contain the address of 00605,000. Okay, so in this case all 8 hexadecimal has a value. All 8 hexadecimal has a value. So in this case, okay, you are needed to load 0x00605,000 into T1. Okay, into T1. So they must contain, T1 must contain this value. So first is that load upper immediate. Start with the upper 16-bit first. Okay, so T1 must contain 0x00. Take the first 4 hexadecimal numbers. So 60 to be loaded into T1. So in this case, T1 would contain 0060, right? And then if you want to load 5,000 in T1, then you can use or immediate. Or immediate, register T1. Tak ada koma. Okay, this part, sorry. Okay, so or immediate, T1, and then 0, then we can take out the lower 16-bit here. Okay, so this is for hexadecimal, right? So the lower hexadecimal, so 0x5000. Okay, so 0x5000 or with the previous content of T1, which is in this case 0000. Okay, T1 contains 0060, okay, when you load upper immediate, the first 16-bit will be loaded with this value. And then they would add 16-bit 0 at the end for the lower half. So then when you OR this, okay, when you OR immediate, so what happened is that 0060 and then 0000 or with 0x500. So 500 is here, 500. So here, immediate here is referring to the lower hexadecimal numbers. Okay, lower part of the hexadecimal numbers, and then the upper part is all 0. And then when you OR it, when you OR the operation, so 0 or 0 is 0, this is 0, or this is 0, 0 or 5 is 5, 0, 0, 0. Hold on. Now you will get the full version of T1 has been loaded into T1. So you would need for this 32-bit data, okay, to be loaded into a register, you would need 2 instructions. One is the load upper immediate, and then another or immediate. Okay, or immediate. Okay, so for this instruction, as in the example 97. Okay, and then or immediate is I format. Using the I format, you should know about this. Okay, what about load upper immediate? Load upper immediate is also I format. I format where RS is not used in this case. Sorry. Okay, so mana pergi color ni? I want to change the color. Hold on. Okay, so to represent it in I format, load upper immediate is the opcode. This one is RT. Okay, and then this one is immediate. So in this case, for your I format, okay, your I format would contain like this, opcode, RS, RT, and then immediate. It would contain load upper immediate. RS is 0. RT contain T1. And then immediate contains 0x0060. So in this case, this is like register 0. RS here. If it's 0 means it is all 0. So you can just use the register 0 in this case. Okay, because there is no value for that. So this will be your how you want to encode for load upper immediate. Okay, that's it. And then the next example, the last example here, let's say you are using a command, consider the initial value of T1 contains 004, 0000, right? So the following two assembly instruction, assemble to the same, do the following to assemble, this one. Does this command would produce the same, machine instruction? Okay, does it produce the same machine instruction? Or does it produce the same output? Does it produce the same output? So, so here, or immediate, T1, and then 0x00C4. So it means that the initial value, so let's say, the initial value of T1 is, okay, now I know. The initial value of T1 0004 0000, betul tak? Okay. Now, when we do the OR immediate T1 or immediate T1 and then 0x00C4, what happened is that the content inside the T1 will be ORed with 00C4. So in this case, 0000, and then OR it with 00C4. So in this case, we extend the bit, sign extend. Now you can have the operation OR. So when you OR it, you will get 4C004000, like that. Okay, so this is the final value that would be stored into OR immediate. But what if you run OR immediate T1 register 000C4? Okay. If you write OR immediate T1 register 0,0x00C4, what would happen is that the source is register 0 or with 00C4. So 1, 2, 3, 4, 1, 2, 3, 4, and then 00C4. Extend it 4 hex numbers, 40 hex. And then when you OR it together, what would you get is C4 only. Okay. So the previous T1 that contains 004 would be override. Okay, would be override with this value. Okay, we will override with this. So you can also say or immediate can be used to initialize. So you want to initialize a new value and override the previous value. So then you can use this kind of command, register 0 and then a value, a new value, then you can override the previous value. But if you want to use the previous value and then OR it together, okay, so it will become a new value. Okay, it can also become a new value, but in this case, they would OR it with the previous value here. There's a previous value in T1 and then OR it together with another constant, another immediate, then you will get a new value. So there is a difference between this command and this command. Okay. Now, so let's do a program. Let's do a program that can write that can load and store word. Okay, that can load and store word. So in this case, I'm using this command. Okay, so I would refer to this command. First is that okay, so first is that I want to I would like to load. I want to load a certain value. I want to load one value only. Okay, I want to load one value only in a register. So first is we start with data. Dot data. Okay, and then if you have a variable, so in this case, marks. Okay, mark, and then dot word. So what are the marks that you want to put? Maybe 40 like that. Okay, so only one data, only one data for mark that I want to store inside my memory. So and then I will start with text. Text is my coding. So starting with the label main as my main program. So now I want this data can be loaded into my registers. So I would use load word register as 0 as my base register. Load upper immediate. Load upper immediate and then register as 0 as my base register and then add 0x1001 because my data start at 1001. Okay, my memory data start at 1001, 0000. So means that the lower half doesn't need to do anything. I can just use the load upper immediate. So when I put a command load upper immediate at 00x100x, so here means base register S0 contain 0x10010000. Like that. Okay. Now, now I have created my base register. Then I can do my load word. So load word. So where do I want to load my marks? Where do I want to load my marks? So maybe I can put it inside T0. And then always, okay, when you store the first data, it will start at offset 0. Okay, we always start at offset 0. And then put the register base there. So our register base that we create in LUI is S0, right? So you copy back the S0. Now you can say load 40, okay, into T0. Okay, and then let's say I want to add. This is my carry mark for the previous assessment. Now I want to add. Okay, I want to add 10 marks on my carry mark. Okay, so ADDI register T0 and then So my mark is in T0, right? So I want to store it back in T0. So I would use register T0. Here, the second one is referring to the previous value in load word, right? So T0 on the second one is the source. And then I want to add 10. 10 marks for my new assessment to be saved back into T0 here. Okay, so in this case, T0 is equal to T0 plus 10 mark. Plus 10 mark. Okay, so you want to store back the previous T0 into the T0. And then, after I add, I want to save it back. I don't want to forget it. So I want to save it inside my memory. So when you want to save it back inside your memory, then you use store word register T0. Okay, so here is the confusion. Okay, so do you want to save it back on the same position? Or you want to save it on the next one? Okay, the next offset. Okay, so if you want to save it on the same position, then you use the same offset, register as 0 like that. Okay, save on the same offset. This one. But if you want to see the changes, let's say, for example, let's say for example, like bank account. Okay, bank account. Whatever transaction that you have, it must be recorded, right? So let's say I want to save a new amount into my bank account. Then if I want to save it and then I want to see the record, then I have to save it in a new space. Okay, new offset. So in this case, I will put it on the next offset. So I will add 4 after that. I would add 4 after that. So 0 plus 4 is 4. Then this is on different offset. Okay, so there's a difference there. So if you want to save it on the same offset, then save it on the same offset. But if it's on the different offset, then save it on the different offset. So that's it. Then save it like that. Okay, so I would save it on my lab exercise assembly program. So I would load it here. So as you can see, my data will be loaded at 1001,000 on the first offset. Index 0, This is index 0. This is index 1. This is index 2. And then this is index 3, like that. And then when you want to try to run the coding, okay, press F10 here. Okay, now we start with load apa? Immediate. So load apa immediate is to create your base register. So your S0 will become your base register. So I will press F10. One line on your load apa immediate. So it will go to the next line, right? So now you can see the changes is in S0, 1001, 0000. So now when you run the coding again, now load word from the base register 16 plus with offset 0, then load the data into register 8. So it should be 40 here to be loaded into register 8. So look at the register 8. So this is in hexadecimal. So change it to decimal. Now you can see 40. Okay, 40 has been loaded into T0. And then when I try to add 10, I want to add 50, I want to add 10 marks on my T0. Okay, now I will get 50. Now we get 50. So, so 50 inside your T0 will be loaded into offset 4. Offset 4. So, when I press F10 again, there's no changes, right? Actually, there's no changes on the register, but there's a changes on the data. As you can see, 50 has been saved inside your memory. So this is how you want to write load word and store word. Okay, so load word and store word. So that's where it comes your exercise. You will do the questions 3 and 4, but open the where is it? Where is it? This one. 1BITZ S1G1 lab exercise. So you only have 50 minutes. Okay, 50 minutes left. But each of these exercise consists of 3 attempts. Okay, so let me give you the high chances on how to answer it within the 30 minutes. Alamak, start attempt ke? Boleh lah. Okay, now, when you read the coding, when you read the instruction, run the following MIPS program in QtSpim. Write down the effect of each instruction towards the register content respectively. Actually, it's not. This content is only after the program execution. So, in this case, copy the coding here. Copy the coding. And then, paste it here. You paste here. Kenapa dia jadi macam ni? Itu betul. Okay, now. Okay, so if it's like this, delete the comment at the top of it. Okay, delete at the top of it. So it will become like this. So now, even the comment tu, you delete it. That part. Only delete that part. Okay. So now the comment become one line. So there's no error. Supposedly there's no error. So and then save it there, and then run the coding. Okay, so save it like this, and then I would run the coding. Okay, run balik. Okay, I would run back again, and then I would run it at the end of it. I would run it at the end of it like that. Okay, so if you're not sure, press again. Then they say, oh, attempt to execute, right? So abort. So make sure it is in hexadecimal. Set it in hexadecimal number in integer registration. Then you can answer your question here. Okay, you can answer your question here. Answer in hexadecimal value. When I say hexadecimal value, means that the value must start with 0x. The value must start in 0x. Okay, understand? So it must start in 0x. Okay, as for the next question here, this is a trace table. The bottom one, this is a trace table whereby you need to execute one line at a time. Okay, so the following programs would return in T1 the sum of all elements in the array. Run the MIPS code in QtSpim. In this case, copy this, and then okay, and then save it here. Okay. So, when you want to load the coding, and then open like this, run it until you reach the load upper immediate, right? Okay, so press F10. Now, the T0 contain the base address, right? So, now, when you want to trace it, you must run one instruction at one time. So, the load word must be executed first. Okay, so you must F10 again. Okay, so the highlighted goes to the next instruction. So, now you have execute the first instruction, load word T20, T0, right? So, then you can copy the value here. The content inside T0 until T3, and then using hexadecimal. And then the content inside the memory, which is in offset 0, offset 4, offset 8, offset 12. So here, go to the data and then look at the offset 0, offset 4, offset 8, and then offset 12. Then you can copy. This data must be in hexadecimal. That's it. Okay? Alright, so you can continue, you can start with that exercise. Before that, don't forget, okay, don't start first. Listen to my explanation. you have a lab assessment. That one is for your lab exercise to check for your attendance and then to check if you understand the question or not. And then the next one is your lab assessment, whereby you need to write the coding based on this problem. Okay, so remember when I said you will have a lab test that you need to write your MIPS code, right? So this is the first preparation. I will give you a problem-based question. So for example, a bank customer has a saving account with an amount of 50 ringgit. Write a MIPS code first. Okay, write one program, one program that contain this part, this process. First, you need to write the amount of 50 ringgit from the saving account. Okay, the keyword is read from memory the value of 50 and then put it somewhere. Okay, put it inside the register. And then the second process is that user want to add the saving. Okay, add saving 100 ringgit into his saving. Lastly, after the add saving, then the system will store the new amount into the memory. So means that store into memory the new amount. How to write that? Okay, so this would be 1 week assessment. So you can write it as if you can have the right operation, then you can just submit it. So the submission is that once you have write the coding and then make sure it is correct, and then copy this. Okay, copy the right coding and then paste it here, and then I can see that if it's correct, then you will get the answer lah. Okay, I can just look at the coding here and then run it on my own. So that's it for the lab assessment. So now, given the time here, so please answer the lab exercise first because the closing time is 1 o'clock. 1 o'clock. So you may start now. Okay, you may start now. If you have a problem, please tell me, unmute yourself and call me. Okay, so I would mute myself right now. Okay, so please do now. Okay, for your leg exercise. I will look at your progress at 12:30, at 12:40. Okay.
Hello, madam. Madam ada ke, madam?
Yeah, ada. Sorry. Yes.
Actually, madam kan, how to do it lah? I can, I cannot do actually.
Show me. Let me close my webinar kejap. Okay, show me. What did you do? Muhammad
I didn't
Zarif.
even do it yet because I don't know what to do.
You don't know what to do? Okay, go to the lab exercise.
Okay, next.
Okay. Did you attempt?
Yes, already attempt and already see the question.
Okay, if you see the question, hold on, let me see what responses. Kejap. Muhammad. Tak ada nama Muhammad. Zarif. Okay, let me see your attempt.
It's empty, madam, because
I know. Hold on. No worries. Okay, now.
okay.
Okay, so now it's empty, right? So I would not edit for you. So I'll just show you how to do that first. So that run the following mix program in Qt Spim. So first is you copy this part and put it on the notepad like that. So make sure there is no comment that exceed the next line. So here it says that number can be represented in by word.data type, right? So you delete that part so that there was no error. So the comment must be in one line. Done? Are we done?
Okay, jap. I'm copying.
Okay, copy.
So the comment that start with the hashtag
Comment start with hashtag tu, you remove that part first.
Alright.
Okay, so or if I do it like this, sometimes if I write it like this, right? Yeah, I've copied from the start and this program will read numbers from data memory like that. So what I do is that Control A, Control V like this. So as you can see, there's a comment. This comment should be there are two ways to read data from memory. One is on the left module, another way is using LUI refer below. So it exceeds more than one line, right? So what would I do is that put a next line, put a hashtag, and then put a next line, put a hashtag.
Oh, like that, okay.
Done. Okay.
Save.
So then you can save. When you want to save as, and then make sure it is in assembly code like this and .asm to make it easier.
.asm.
Exercise question 1, Lhasa, .asm. Save as type all file. Done? And then
Okay,
just put it on the desktop. So it's easier for me to find it. So and then I'll just save it. Okay, now I'm already saved. Then go to the Qt Spim and then find the ASM file and then open and then it was loaded. It was loaded, right? So right click, change to hexadecimal. Change it to hexadecimal.
hexadecimal. Where to change it?
Right click
Oh,
on the
okay.
data. Right click on the data. Okay. Sorry. Don't right click on the data. Click the data tab.
Okay, data. Okay.
Okay. It should be in ABCDE 080.
Yes, same.
Okay, same, right? Okay, go to the text.
Okay, text.
Go to the text. Now, make sure the register here, go to the left pane of the register, right click, and then make sure hex is selected.
Okay, yeah, it's already in hex.
Okay, good. Now, when you want to run the coding, okay, so you should look at the 0040024. So the starting of your coding start at 24. So when I press F10 until 24, then I need to wait. Okay, I need to check, okay, where should I start, right? So the coding here only give you register content after program execution. Means that I'll just run the coding until the end of it. Until the end of it. So what I do is that F10, 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 and F10. That's it. Dah.
So just press F10 lah
Just press F10.
until the end of the line.
Yes.
Okay.
And then you will get your content there. You will get your content. Dah.
Okay, already on the same like you. But I don't
Okay.
know where is
The
the
red
content.
color is on the T4, right? Correct.
Alamak, why I'm at the T3?
Then press F10 again.
Oh, F10 again. Oh yeah, at T4, yes.
T4 already red, right? Okay,
Yes.
now your data is completed. Okay, now you can load your answer. PC is at the top, this one. Okay, so this one is referring to this part. Okay, but in this case, remember when I said PC plus 4. PC plus 4 means the current version is 38. So the next instruction should be 3C. So then use a full one, the full size, because of they omit the 00 tu. So you need to complete 8 hexadecimal number. So 004, 000, follow this one, 3C.
3C.
And then, like I said, answer in hexadecimal. So hexadecimal must start at 0x. Always start at 0x. Like that. Okay, boleh? So that is for PC, right? Okay, S0. S0 contain 1001, 000. This is also from your memory. So start at 0x also, kan? So copy this inside the S0 and don't forget the hexadecimal symbol 0x.
0x. Oh. So I just need to put 0x and paste the number S0, right?
Yes. And then also the T0 also the same. As you can see, this is the value after the operation. So ABCDE 080. So means this is a load word. Here. So load word will contain, they take out all the value. And then load half. Load half should take only 4 hexadecimal number and then they would fill in all F. Then copy all. Copy all. Copy all of it. So don't forget the hexadecimal value. This is in hexadecimal value, right? And also T2. So T2 only 1 byte. So they only take out 2-digit hexadecimal and then the rest would be filled in with F. And then the next instruction is LHU. So LHU means they omit the F. So this time, they only take out the 4 hexadecimal. So E080. So how do you want to write that? Copy this and then put the hexadecimal symbol and then that will be your value. That will be your value. Okay, that you need to put inside here. Okay, and then T4 is also the same. They omit the FFF, they remove the FFF, then only the 2-digit hexadecimal is left in the T4. So don't forget this is in hexadecimal, then don't put the symbol for hexadecimal for your answer. That one.
Okay, I try first lah.
Next, go to the next. Boleh, you can go to the next. It doesn't, I did not restrict that part. Okay, next part.
Okay,
Copy back again the coding.
Okay.
Okay, now paste it on the same coding, right? Or maybe put it on the same coding and then save it another save as. Another save as. And then .esm. Don't forget save as type all file so that I can differentiate between these two coding. So dah.
Dah.
Done. Okay, now if you check, okay, the comment tu it's on one line, so there's no problem, should be no problem. So now you can load the coding first before you want to run the coding. Okay, so now load the coding first. Load the coding. And then F10 until, alamak cepat sangat lah. Reload back again. Too fast. Okay. Okay, so before we want to run the F10, check back the instruction here. It says the trace table must be run execution one line at one time. So start at load word T20T0 means after load of immediate. After the load of immediate, then you need to check the content. Sorry. After load up immediate, then we can start the trace. Okay, the tracing. So we should trace the content of T0, T1, T2, T3, and then the content inside the data memory after you run the load word T20, T0 here. So I cannot make it too fast. Okay, now. Okay. So now we are in load up immediate, right?
Okay.
Dah F10 until load up immediate. Done?
Tengah baru load file.
Okay, so now you should load. Okay.
Alamak, why is a label is defined for second time? There's some error.
There's some error. I don't understand.
When I load the ASM file for the second question, there's a error pop up.
Enable kan awak punya tu share screen. Sekejap, saya unshare my screen. Cannot see the coding. I've never had the coding macam tu. Error, I never had the error. Make it bigger? Tak boleh. Kejap, saya kena tengok. Go back. Tadi.
Okay.
Label is defined for the second time on line 7 on main. Okay, go back to your coding. Buka coding tu, saya nak tengok. Data text min. Is it the same coding?
Yes, I copy from the question lah.
Copy from the question. Okay. Ni dah save kan? Okay, load back the file.
Okay,
dekat QTSP. Abort dulu.
Oh, abort dulu. Alamak. Okay.
Cancel.
Okay, cancel. Okay, next.
Macam mana nak pergi balik yang tadi abort tu? Alamak, ai.
Dia kena run dulu. Kena open dulu je. Saya nak error tadi tu ni.
Abort.
Okay.
So pergi load balik yang second punya. Second. Bukan yang tu. Jangan load. That's why dia error.
Oh, second kat mana?
Second icon tu, cancel. Go to, yang that one, reinitialize. Kita restart again. You restart back again your coding. Okay.
Klik ni Okay.
And then, open. Kan tak keluar error. It's because of the previous coding is also included on your coding. That's why ada dua main. Dia jadi dua main. Dia masukkan lab9.asm and then they include also lab92.asm inside the user tag segment. They are running two coding at the time. So if you don't want that, you use the second icon that reinitialize and load file. Then tak ada error. Dah.
Dah.
Okay, now. Go, we don't have time. Okay, go F10 until very slowly, until it reach load upper immediate there. Until 24 tu. Until it reach memory address 24. Then slow. Okay. Alright. Go to your, apa tu namanya tu, dekat ulearn tadi tu. Go back to your ulearn. Okay. Okay, put it side by side. Okay, senang awak nak tengok nanti. Okay. Now. Okay, so go to your QTSPIM here. Okay, go to your QTSPIM. Tekan F10 one time. Okay, now it is at T0, right? Okay, T0 has been loaded, but you need to run the load word T20. Okay, T10 again. F10 again. Now.
T2.
Okay, slow. Okay, now. Your content here should be T0, T1, T2, T3. You should copy and then put it on the text box for the first instruction. Load word T20, T0.
Macam mana?
Okay.
Okay.
The content for T0 is this one. 1001, 000, and then you need to copy and then...
This one
Okay. Copy. And then put it on the first text box for T0.
This one, T0, right?
Yeah. Put it there. Paste. Don't forget, this is in hexadecimal.
0x.
Okay. Okay. Now, T1 contain apa?
0.
Then put 0.
Only 0 lah.
Type je.
Okay.
In hexadecimal.
Oh, need that 0x also lah.
Also must. Okay.
Okay.
T2?
T2A. So,
Then
0xa.
macam tu je.
Okay.
Okay.
T3 also 0.
Sama. Okay, so how to see the content of your 0 T0 here, right? So if there's a bracket, it means it refer to the offset 0 dekat memory. So go to the tab data. Pergi kat tab data.
Data.
Okay, so the first column tu is the first offset. Offset 0. Nampak tak?
Mana tu?
Online
Ni, atas ni.
No. That one, the second line.
Second line. This.
See the data there? Okay, so that's your data. You copy it on the first one.
So
On
this is the T0 lah.
Yeah, no. T0 contain the address of 1001. But here there's a offset 0 kan? So this is A here is for offset 0. The first column is offset 0. So you copy that one. And then put it there.
Offset 0. Need the hexadecimal.
Also.
Okay.
Faham? Okay.
Alright.
So the offset 4 tu means the second column.
Oh, the next lah.
Okay. Sama. And then run again. Macam tu. Put it there. Okay.
This one lah last. The third one.
8 here is on the third one. 8 here is on the third one. Macam tu. Okay.
So the 12, the last one.
Last one. Last one. Okay, now understand? Okay, so go back to the tab text tu. Okay. So now we need to run F10 again one time.
F10 one time.
Okay, now there's a changes there and then I'll buat repeat lagi sekali one time, buat satu line, one line at one time. And then follow
so the next new value just replace it lah. So like this one.
Yes. Betul. Now you see the
Okay.
changes, right? You will see the changes. A doesn't change. 1, 4 change, and then you need to even if it doesn't change, you still need to copy. Benda ni kena sama. It must be the same. Value tu even it does not change, you need to copy back again. Like that. Faham?
Okay. Alright.
Okay.
That's all. Thank you, Ada.
Okay. Already done? Okay. Oh, if you have done, please do you can just do the other lab assessment, no problem. Hamza. Where is Hamza? Hamza, why you did not attempt the lab exercise? Where are you, Hamza? Nani? Tengok Mira.
I'm here, Daksha.
I know you are there. Please answer the question. Go.
Okay. Done now.
Run the coding. Okay, run the coding. I want you to use the 50 spin. Okay, if I ask you to do the coding at the moment and then everybody show the screen, so it will take a longer time. So Aisyah, Anissa, Nubatisha, Fitria, Ida. Ida mana? Oh, Ida. Syafiqah, Ida. Aisyah, Surya.
Madam.
Ha?
Kenapa saya tekan F10 tu dia tak load
Tak, load. Share screen. Saya tak tahu macam mana awak buat. Show me.
Jangan.
I don't understand the error tu. Saya kena tengok error dia tu dulu baru saya tahu macam mana buat. Okay. Screen saya kecil.
Ni.
Duduk. This one has been loaded. Okay. Okay. Sekejap Now if you press F10 what happen?
Apa kalau dia macam ni keluar set breakpoint.
Cannot F10. Do you know the step tu after the button yang ada, nampak tak button stop kat atas tu? Play, pause, stop. Ada sebelah dia tu ada number.
Oh ni.
Adalah right segment. Ada
This one.
Tu single step. Ni. Boleh je.
Oh, lepas ni baru F10 lah.
F10.
Oh.
Button dekat keyboard tu kena F10. Ada tak? Button keyboard F10 tu. Dia tak boleh. Kenapa dia keluar tu?
Ada tapi
cuba pergi dekat saya nak tengok awak punya setting F10 awak lah. Sekejap simulator. Go to the simulator tu. Can you click dekat menu simulator? Tu nampak tak? Dia kena tekan F10 sebagai shortcut key tu. The shortcut key for your single step.
Tapi saya tak boleh.
Tak boleh juga? Tak apalah, pakailah ikon tu je. Tekan je button single step tu.
Oh, tekan ni je.
Tekan je button single step. Tak masalah pun. Macam tu.
Oh, okay.
Boleh je.
Okay.
Problem with the keyboard tu kot. Dia sepatutnya dia tak boleh macam tu. Boleh je ni.
Okay. Thank you, madam.
Who else is not attended? Okay, 25. Should be, including me inside the Teams is 26. Betul. Correct. Aida, why is it wrong? Why did you get 1.45 ni? Salah ni. Let me see.
Tak sempat nak jawab lah madam tadi.
Try again. 3 times. You have 3 times. This time you should. Tapi there is less than 10 minutes.
Boleh extend sikit tak pun?
Nak extend?
1:15, 1:30.
15 what? I don't understand. 15 apa?
Add 15 minutes more.
Hold on. Sekejap.
Need to get used to it first.
I know. I'll give you...
Okay, baru boleh.
I'll give you
1 week, Doctor. 1 week.
No 1 week. This is only attendance. Doesn't need to take too long lah.
It's okay.
Boleh nampak aku ni?
1:30. Now I have extended 1:30.
Saya punya screen ni.
Sorry, sekejap. Apa benda? Okay, now. Right, I have extended for 1:30. Should be okay.
Boleh nampak?
Apa dia? Sekejap ni. No, it's empty. No.
Tengok ni. Tepi ni.
Tengok, tak nampak. You need to share your screen.
So untuk PC yang ni semua follow yang mana?
Surya kan? Imun. Can you share your screen? Dah, dia dah mute dah.
Oh, madam. Ya.
Can you share your screen? The one that you want to ask.
Oh, tak. Okay, sudah okay.
Sudah okey pula.
Okay, sorry.
Okay, I'll close the session. I'll end the meeting today. Okay, so you can just continue. You can just continue the question. Okay, so I'll start recording.